Hello everyone, welcome to this channel of Easy Study. Today's topic is polysaccharides.
Role of polysaccharides. Polysaccharides serve plants and animals in three ways: as structural materials like cellulose, hemicellulose, pentosan, and pectic substance provide structure to plant cells. Similarly, chitin and mucopolysaccharides serve this purpose in animals. Then, the structural polysaccharides are indigestible in small intestine. As a result, they provide bulkiness in the diet and helps in the bowel system or excretion. Next is starch, dextrine, and fructan in plants and glycogen in animals serves as food reserves. Therefore, they are utilized by the human body for its metabolism. Last is polysaccharides attract water and retain water so that the metabolic or enzymic process are not impeded under properties of polysaccharides. Polysaccharides have this very important properties for its hydroxyl bonds that helps it in interacting with water. There are great differences among the interaction because some disperse rapidly in water, some are quite insoluble, and others disperse as swollen particles or globules. A few carbohydrates form clear solutions at moderate concentration, some form gels at low concentration, and some form gel at high concentration, and others do not gel at all. Some form gels that are translucent and others opaque. Hydrogen bonding between sections of different molecules can result in the formation of crystallite region. Linear polysaccharides can associate through intermolecular hydrogen bonding to form gels, and if the solution is dilute, it may result in precipitation. Starches are abundant polysaccharides in most cereals. Starch is composed of amylose and amylopectin. Amylose is the linear chain structure, that is the glucose unit linked by alpha 1,4 glycosidic bond. And amylopectin is the branch chain linked by alpha 1,6 as well as alpha 1,4 glycosidic links. Amylose is truly not soluble in water but forms hydrated micelles, and it is responsible for the gelling characteristic of cooked rice. And amylose turns blue in iodine solution. These are some of the important points. Then amylopectin is responsible for the thickening structure of rice. In rice like waxy rice or low amylose rice, the content of amylose, or there is no amylose present, but amylopectin is present majorly, whereas the rice, non-sticky rice, usually has higher concentration of amylose of around 20 to 25%. Important terminology with start is gelatinization. For example, let's take a rice starch, rice grain. So, if a mixture is heated in the presence of water, intermolecular hydrogen bonding in the starch granule is broken and the grain absorbs more water and swell. The temperature at which the granules begin to swell rapidly and lose its birefringence is called the gelatinization temperature. As the temperature of the starch suspension is increased above the gelatinization range, the grains begins to continue to swell, and it keeps on swelling until it is completely gelatinized. As a result, the sample gets thickened, or in case of rice, it gets cooked. Cooking can be considered as 99 or 100% gelatinization of the starch molecule. Terminology is retrogradation. Retrogradation is related to gelatinization because the gelatinized starch, when cooled for a long or enough period, will thicken and rearrange itself again to a more crystalline structure. This process is called as retrogradation. During cooling, starch molecules gradually aggregate to form a gel. Few terminologies that are important for exam like retrogradation, dextrinization, Maillard reaction, caramelization. So in exam we are mostly asked about the process or the type of cooking where this phenomenon usually occurs. So retrogradation occurs mostly in stelling of bread, like if you keep a bread for in a refrigerator or just at room temperature for 2-3 days, it gets hardened, the texture gets hardened, so that is retrogradation happening. Then dextrinization, like roasting of chapati, when we roast our roti over a tawa, the starch molecules breaks into small dextrine molecules. That is the reason we get a sweeter taste when we consume roti. Then Maillard reaction happens mostly in bakery products like baking of cake or your biscuit cookies. So in starch plus protein mixture, the bakery mixture is mostly your flour, which consists of both starch and protein, then like sugars and all. So that happens because the amino acid from the protein and the your glucose or the any sugar from this molecule, starch molecules, reacts and they form something like of a glucosamine, and that gives a browning color to the baked products. So mostly we see the browning of the cake crust is because of Maillard reaction. Then caramelization is nothing but when we just heat sugar without the presence of water, we see a browning, thickening, a thick liquid. So that is caramelization. We mostly use in a caramel custard or caramel popcorns, like that. So these are very important terminologies in terms in exam for exams. So thank you for watching this channel.